Hello everyone and welcome to this webinar. My name is Zelga and I'm one of the regional sales managers here at Scandidus. So we are here today to talk about the wireless Delta4 Phantom Plus system that offers the most accurate and most efficient verifications of your IMR TV mat, Halcyon, Radixact and TomoTherapy plans. So Scandidus offers a family of products covering QA from planning to final fraction, where the Delta4 Phantom Plus is our solution for the pre-treatment verification phase. And the questions to be answered here are, is the plan deliverable? So is the plan correctly transferred to the accelerator control system? Is the machine capable of delivering the plan? Is the MLC performance correct? And also, is the leakage correctly moduled in the TPS? So for that, Scandidus has introduced the new Delta4 pre-treatment system. It has been redesigned from bottom up with the next generation detector technology. The Delta4 Phantom Plus offers faster setup, where the alignment is done in seconds with clear markers on the Phantom that allows for accurate positioning of the Phantom. Easier measurements, so by having the Phantom instantly ready for measurements without any warm-up. So you can just turn on the power and you are ready to measure. And also less and easier calibration procedures. I will talk more about the calibration procedures later on. And with this, the Delta4 Phantom Plus enables an efficient workflow where at least 6 complex plans can be verified within 1 hour. The Delta4 Phantom Plus also offers easy handling. And this is because the system is completely wireless. The communication to the PC is done through Wi-Fi, so no communication cable is needed. The system is battery operated and therefore no power cable is needed either. The capacity of the battery is more than 4 hours, but if you would run out of battery, then you can just charge it while using the Phantom. And with electrometer technology that is much faster, the detection of the dose pulse from the accelerator can now be done by the internal electronics, which eliminates the trigger cable. However, we still measure pulse by pulse, which is the most accurate and the only way to ensure that individual control point doses can be measured. The Delta4 Phantom Plus uses new highly stable detectors with a sensitivity decrease of only 0.04% per kilogray. So it needs more than 25 kilograys to lose 1% sensitivity. So if you do a lot of QA, say around 500 QA cases per year, with a mean fraction dose of 2 gray, that is 1 kilogray per year, the detectors would remain within 1% for 25 years. So the need for recalibration of the detectors is reduced to once every 25 years. And 25 years is a long time. It's actually longer than the lifetime of the system itself. So therefore, there would be no need to perform relative recalibration nor directional recalibration at the clinic. Regulatory requirements may be different for every country, of course, and one might need to do relative recalibration annually. And of course, you can do that, but it's good to know also that the calibration procedure is improved and is much easier and is done in the measurement Phantom and does not require any disassembly of the Phantom. The cylindrical Phantom also has inserts for different ionization chambers. This allows the absolute dose to be verified with an ionization chamber directly in the same Phantom. It also allows the absolute calibration to be performed without any disassembly of the Phantom. and this is convenient when you want to do calibrations on different accelerators. Inserts are available for common cylindrical chambers like the Farmer, Semiflex, and so on. And also the system offers independent check of absolute point dose. The geometry of the detectors in the Delta4 Phantom Plus has a plus configuration, hence the name Phantom Plus. This is a patented configuration based on two orthogonal detector planes aligned in the cardinal directions in a fixed geometry, providing full coverage of the cross-section of any beam direction. Thereby, the intensity modulation of the treatment delivery can be verified without missing any data. This also means that we now measure in the sagittal and coronal planes, and this is often preferred as it corresponds to the planes that are used when the patient is planned in the TPS. A superior advantage of the detector design with the two orthogonal detector planes is that it provides real measurements in the isocentric target region and steep dose gradient regions with high accuracy. Hence, dose in the target region and the ORs can be evaluated without the need of reconstructing the dose. In total, the detector planes contain 1069 p-type silicon diodes, and the central 6 by 6 square centimeter region of each detector plane, the resolution is 0.5 centimeters. Outside of this region, the resolution is 1 centimeter. The resolution in the isocenter can be increased to 0.25 centimeters by merging fields. The merging method allows for fields with lengths up to 38 centimeters and the superior-inferior dimension to be measured. The fixed configuration of the detectors benefits the resolution compared to moving detector coordinate systems where the smearing effect of the measured dose is present. Due to the configuration of the detector planes, the target dose and the dose homogeneity in the target are typically measured in several hundred detectors. The Delta4 Phantom Plus also offers easy handling and fast setup, typically within 3 minutes, where the Phantom is easily and ergonomically transferred to the treatment couch using the Delta4 trolley, where no lifting is required. I will here very shortly mention the Delta4 Phantom PT, which is the old version of our Phantom. So this is a survey that was done by an independent company that asked customers how much time they spend on pre-treatment verifications when using different equipment. The verification process was divided in 3 phases: the preparation phase, the measurement phase, and the analysis phase. The preparation phase is everything from setup to calibration of the system, practically everything that needs to be prepared until the actual measurement. The measurement phase is the delivery of the plum or the beam, selecting the next beam and measure, and so on. The analysis phase is how much time you put into analysis, how many clicks you need to perform to get the analysis results, how much time you need to analyze the results, and so on. So we see here that for the Delta4 system, and as I mentioned, this was done for the old version, the Delta4 Phantom PT, we see that our Phantom was equal or a little bit worse compared to the competitors in the preparation phase. Whereas in the measurement and analysis phases, we were superior compared to our competitors, which means that we have easier and more user-friendly software that is fast. But we were, of course, not happy with the preparation phase, so that is what we focused on when we developed the Delta4 Phantom Plus. So if we had done the survey for the Delta4 Phantom Plus, it would probably look something like this. We know that it takes approximately 5 minutes to set up the Delta4 Phantom Plus. So comparing that to the numbers of our competitors, this means that our system is 55% faster in total, so for all phases. So to continue more with comparisons, we will now look at why the Delta4 Phantom Plus is better than EPID. So first of all, the EPID is not intended for dosimetry measurements. It is an imaging system. And for it to be used as a dosimetry system, one needs to do time-consuming commissioning, and this is also due to the non-linear dose response in the system. This then results in low accuracy and low contrast. The EPID is a 2D array system, which requires reconstructions to get the dose in 3D. And we all know that as soon as you apply any kind of reconstructions, you lower the accuracy. Although the investment cost might be low since the EPID is usually included in a purchase of a LINAC machine, the EPID will be expensive in the long run since it is not made for exposure of high doses routinely. Using it for dosimetry measurements will shorten its lifetime and therefore increasing the costs in the long run. Since the EPID system is delivered by the same vendor as the LINAC itself and is part of the LINAC, it is not an independent system. Last but not least, according to the TG 218, it is recommended to do patient-specific QA with a stationary measurement device system placed on the treatment couch. Also here we have competitor analysis where we are comparing the Delta4 Phantom Plus with a wrapped 2D array and a rotating 2D array. So to compare diodes with ionization chambers, ionization chambers have relatively large volume, potentially resulting in a loss of accuracy due to the volume averaging effect, which is a characteristic for ionization chambers in modulated fields. And to actually measure in the target and steep dose gradient regions provides real measurements with the highest accuracy. The Delta4 Phantom Plus has the highest resolution on the market. And with our highly stable detectors, the Delta4 Phantom Plus requires no relative recalibration. With our intuitive and very fast Delta4 software, that my colleague Madeleine will tell you more about shortly, you get instant analysis results as soon as you hit beam off. And due to the configuration of the detector planes, the 3D gamma analysis is based on actual measurements. Our system, as I mentioned earlier, is the only completely wireless system. And also, as I just recently showed you, the Delta4 trolley provides easy and ergonomic handling of the Phantom. And it is, of course, of a huge importance that before I finish this presentation, to also mention that the Delta4 Phantom Plus is compatible for quality assurance of all different kinds of treatment techniques delivered by not only all conventional LINACs, but also the Halcyon, the MRIdian, and the TomoTherapy machines. On our website, you can, of course, find all publications that have been published about our products. And also customer cases can be found on our website. And here is a small selection. And last but not least, a small drop of all our customer reference sites around the world. And with that, I say thank you for listening. Madeleine will now talk to you about the software, the Delta4 software, and show a few cases.
Thank you, Selga. Yes, as Anders mentioned in the beginning of this presentation, my name is Madeline and I am the software product manager at Ethos. I also work as an application specialist. And I'm gonna do this by starting with a short presentation where I wanna just present our software and talk a little bit about the software options that we have to offer. And after that, I'm gonna do a quick software demo where I will be showing you around our software and opening a few patients just to see what you can find in the software. So let's get into it. This is just a print screen of the Delta4 software. We've focused a lot on making our software intuitive, just because an intuitive software decreases the learning curve, and it also provides easy navigation between patients, measurements, and analysis tools. The Delta4 QA process is fully automated. QA results and pass-fail analysis, including dose deviation, distance to agreement, and gamma index, are going to be instantly displayed after finishing a measurement without requiring any user interaction. Since we do perform our measurements in the target region, the relevant dose is available directly after the radiation has been delivered without the need for any calculations. The delivered dose is automatically compared against planned dose and analyzed according to your user-definable pass-fail criteria. So I will show you more about the interface of the software during the demo. But for now, I would like to move on to briefly talk about the different software options we provide, starting with the Delta4 DVH. With the Delta4 DVH, you can calculate 3D dose distributions within the Phantom geometry using your measured values. So this is independently from the treatment planning system. The dose distributions are calculating using a ray tracing technology, and the results will be instantly available after you finished your measurement. The Delta4 DVH also allows you to overlay the structures outlined during the treatment planning onto your dose distribution and to display dose volume histograms inside all of these structures. From the publication Tolerance Limits and Methodologies for IMRT Measured-Based Verification QA, recommendations of the AAPM task group number 218. Gamma statistics should be reviewed on a structure-by-structure basis if the user software allows for it. Vendors should include this feature in their future software development. With the Delta4 DVH Professional software option, you will obtain your gamma pass rate, dose deviation, and distance to agreement inside each structure. A small overdose in the target might not be a bad thing, just as an underdose in the risk organs will most likely be positive, and therefore the Delta4 DVH Professional also allows you to edit your pass-fail criteria differently within your targets and your risk organs, making sure the right criteria are used in the right situations. The publication I mentioned earlier also states that software tools that can provide a measure of the agreement between measured and calculated dose volume histograms of patient structures are preferred over analysis in phantoms. The Delta4 DVH Anatomy software module calculates dose distributions inside the patient geometry using the measured values as an input, completely independent from the treatment planning system. Only by calculating the dose in the patient geometry can you get the actual dose that will be delivered to the targets and risk organs during treatment. And the Delta4 DVH anatomy allows you to do this. So this software option includes visualization of the dose distribution overlaid on the patient CT, dose volume histograms of all structures outlined during the treatment planning within the patient geometry, and also structure-specific analysis within the patient geometry. So the purpose of this slide is only to explain that these software options build upon each other. So for example, if your clinic decides to purchase the Delta4 DVH professional software option, this option will include everything that all of the features that the Delta4 DVH option has. And similarly, if you choose to purchase the anatomy software module, you'll also obtain all of the features of Delta4 professional and Delta4 DVH. Finally, I want to talk a little bit about machine QA, because ScandiDose also provides the Delta4 machine QA software option, which allows you to use your Phantom to perform QA of your linear accelerator. Within minutes, you can perform a check of all relevant treatment parameters, such as a symmetry and flatness consistency check, an energy consistency check, a check of the machine startup behavior. You can verify your MLC positions. You can check the dosimetric leaf gap, and you can also look at trends over time for your machine. And all of this is done in compliance with the recommendation of the AAPM task group 142, which is, you might be familiar with it. It's called Quality Assurance of Medical Accelerators. So that's the presentation I wanted to perform, and I'm going to move on to show you a bit of a software demo. So you should be able to see my my Delta4 software right now. This is what you will see when you have just finished performing a measurement of a treatment plan. And what I want to start by bringing your attention to are the free histograms at the bottom of the page. These will be instantly displayed to you, and they will give you your dose deviation, distance to agreement, and gamma pass rate for this plan. The gamma pass rate is displayed for the criteria that you've defined for this particular patient. What I can also do is I can display my gamma pass rate for a number of different distance deviations and dose deviations. So for example, for this particular plan, I have set the criteria 3% 3 millimeters, and I can see that I get 100% pass rate. But I might be wondering, well, what happens if I lower my criteria to 2% 2 millimeters? Then I can use this table to see that I still get 100% pass rate. And then what happens for 1% 1 millimeters? Well, then my pass rate goes down to 97.8. So that's actually a quite neat feature that I use a lot when I'm visiting clinics. I have a few different tabs up here, which are related to different ways of displaying the data. The first one is the beam side view. Right now, I'm looking at the beam side view for the first field. I should say this is an IMRT treatment of something in the pelvic region, probably a prostate. I am right now displaying the beams I view for the first field. I can display the beams I view for each of the control points contained in this field. So this is a result of the fact that we are measuring dose pulse by pulse, which means that we can divide the measured dose into control points, and we can actually see what happens during each sequence of the treatment. So I can get a picture of the MOC positions during this this control point and where the measured dose is. The tab 2D planes is just looking at the two detector boards mounted inside the Phantom, just as if I would have dismounted them from the Phantom and put them in front of me. So I can see that I have the horizontal and the vertical detector board. If I right click on any of them, I can show profiles over the dose distribution. You can see that I get a nice profile here where the dots are representing measured dose, and then the line is representing the planned dose. I have a tab called 3D Phantom where I can see these boards mounted inside the Phantom. You might notice that I have structures displayed here over the dose distribution. The structures, a list of structures will be displayed to the right in the software, and these are all of the structures that were outlined during the treatment planning. If I click on them, they will show up in the dose distributions, and I will also be able to display dose volume histograms inside these structures. So the tab called Axial View shows me the dose distribution inside the entire Phantom volume. So this is a dose distribution in 3 dimensions, and I can scroll through the planes to see how the measured dose is corresponding to the target. I can, similarly to what I could do in the 2D planes, I can display profiles over the dose distribution. I can also see dose volume histograms inside all of the structures I've selected in this list. Moreover, I can get all of my analyses inside the structures. So I can get my gamma index, my distance to agreement, and dose deviation inside all of these structures. In analogy to axial view, I have the anatomy tab, which is going to display to me data on the same format as axial view, but the anatomy data is actually calculated inside the patient geometry, whereas the axial view data is calculated inside the Phantom geometry. So what I can see here is the patient CT, and then the measured dose just displayed over the patient CT. I can still see all of my structures. I can look at profiles. I can look at dose volume histograms, and I can get these the analysis. So the gamma index, distance to agreement, and dose deviation inside these different structures. So this is the data that is available to you when you are using the Delta4 software. I thought I just quickly, so this this plan is measured on a regular linac. I can see this by looking at the graphics here underneath the patient information. It was measured with a variant Truebeam. Just to show you how similar everything looks when I'm looking at data measured by a different machine, I'm just going to open this Halcyon plan, and you can see that now this is a measurement done on a Halcyon machine, but the display is identical. So I still have my fraction statistics where I have my dose deviation, distance to agreement, and gamma. I can look at the data in all of the different views, and it looks the same. Same thing if I'm opening something measured on a TomoTherapy machine. So now this is measured on a Tomo, but the displays look all the same. It's still the same histograms, the same sort of data display with profiles and everything. So this is good because it doesn't require you to learn something new if you want to start using your Phantom on a different machine. Once you've learned the Delta4 software, you know how it works.